All right, hi everyone. This is Unit 2, Mod 7, and we are here. We are in stats class. Okay, not really. We're still in AP Psych, thank God. You do not want me as your stats teacher, but thankfully I can teach what you need to know for AP Psych for stats. So let's get started. You can pause to appreciate my memes. I know you want to. So here's the list of our vocab. If you want to pause this to write anything down, go for it. So why? Why do we have to do stats in AP Psych? Well, we talked about how we can't just believe everything that's out there. We can't just use common sense. We need to do research. Okay, well, in order to do that and actually make sense of it, we need to know a little bit about stats. So be curious, skeptical, humble. Remember those words? There's so much misinformation out there. We need clarity, so we need to be educated about what we're looking for. So the first important set of terms that you need to be aware of, and this is good because, hey, I bet you know these words. So descriptive statistics. So this is just how we visually organize the data. So organizing it into something meaningful. So I'm sure you've heard of a histogram before. If you look over at that bar graph, right? You might call it a bar graph. So that's the histogram, is the bar graph looking part of that graph. And if you look over there again and you see the line connecting the data points, that is a frequency polygon. I'm sure you're familiar with those two things. It's just two different ways to organize the data. All right, so measures of central tendency. So I'm sure you've heard of mean, median, mode before, and I bet you know how to do those things. And actually, you do have to do a little bit of math. Sometimes in AP Psych, you have to do mean, median, and mode. Yeah, you can handle it. So the one word you might not have heard before, though, is central tendency. And so when you see central tendency, don't think range, don't think standard deviation. You want to think getting to the most or the middle, right? So central, getting to the center. So mean, median, and mode are attempting to do that. Now, they're not always successful. So remember, mean, obviously you take your data points, you divide them by how many there are, you get your mean, your average. Median, you take, just like over on the right there, you take your data points from lowest to highest, and you go and you find that middle number. And then mode, that's the number that shows up the most. Okay, so out of all of these, mean can be skewed the most. So imagine that you're sitting at Starbucks in Reading, Massachusetts, and in walks Bill Gates. Okay, now we're doing some data on your net worth of the people sitting in Starbucks in Reading, Massachusetts. Or let's say income, the net income of those sitting in Reading, Massachusetts Starbucks. Well, everyone apparently in Reading, Massachusetts is a billionaire, according to our mean. And that's because that one data point has skewed, and that's a vocab word. Skewed meaning thrown off far to the right or far to the left, but it's thrown off our data so much that it's not useful. Unfortunately for us, most of us sitting in Reading Starbucks, which is sometimes myself, we're not billionaires. So Bill Gates' data is throwing it off. So in those cases, if you stick to median, you would still get a much better description of what the actual net income is like in Reading, Massachusetts. It's a better picture of it. So measures of variation. So varying, how much does our data vary? So you can look at range, right? You take the highest data point, the lowest, and you subtract, and now you have the range. That gives you a rough estimate, but it's honestly not something that's super useful for us. We look at the normal bell curve, and if there's a normal bell curve, it's not skewed to the right or to the left. That is a good sign. I'll show you that on the next slide. And another thing we look at is the standard deviation. So this is probably the most useful thing. It's more useful than range and mean. And what it means, what standard deviation means, is how much does the score vary around the mean. So the mean is going to be the center of our standard deviation. I'm going to show you this on the next slide. So what I want you to remember is the smaller the standard deviation number is, the stronger the data is. We like small standard deviations. Okay, so here's our normal bell curve. So that middle line in the bell curve, that is our mean. That's our average. So when we were talking about how much does the score vary around the mean, that's our standard deviation. So if we are looking at this and we were to say that the mean on a test was a 70, okay, then we put 70 on this graph right at the bottom of that mean line in the middle of that curve. If the standard deviation is 5, we would put, so 70 is in the middle, we would put a 75 on that next line that's sticking out on the bell curve. And on the other side of the middle, we would put a 65. So a 65 on one side, 70 in the middle is our mean, and 75 on the other. So, and if we were looking at this, we'd say, okay, well, how many scores fell between a 65 and a 75? 68%. Okay, do you see what I'm doing there? We're going to work on this in class. I know this is can be a little bit confusing. You really need to look at it a few times. So 2 standard deviations away from our 70 mean, well then, okay, we went 75 over here, so now we go another 5. So 2 standard deviations this way would now be 80, okay? And 2 standard deviations the other way would be 60, okay? So each time I'm taking it 5 out away because our standard deviation number was 5. That's how you do that. So how many people scored between a 60 and an 80? 95%. Okay, so now if you wanted to go to 85 and 55, how many people scored? You try. How many people scored between a 55 and an 85? Yes. Between 55 and 85. 99.7%. So that really includes most everyone, right? So those numbers, those percentages, you do need to know. A bell curve follows the 68, 95, 99 rule, okay? Or 99.7 to be exact. If you remember 68, 95, 99, I think you're pretty good. So my little trick, maybe it works. Picture a 68-year-old lady driving down 95, 99 miles per hour before she gets busted by the cops. We'll go over this more in class. Okay, so when are our differences reliable? When we look at that data and we're like, oh, there's something here, but can I trust it? That's when we want to look at our inferential statistics. So our inferential statistics are the numerical data that we're looking at that allow us to generalize to the population we're studying. So if our study is about freshmen in college, we want to be able to generalize this research finding to all freshmen in college. We have to know it's reliable first. So what are we looking for? We are looking for a representative sample, and a representative sample should obviously be random, but it should also be a large sample size. You don't want to hear that the study was only conducted with 800 freshmen in college. There are way more than that, right? So not that you're going to get everyone, it's a sample, but if they did a study and it's only 800 people, that might not be as reliable as a study that was conducted with 10,000 or 2,000, whatever. So we want large sample size, but we want, as I said before, small standard deviation. If we go back here and our standard deviation is 15, Okay, so again, our test median score was 70. I'm sorry, our mean score was 70, but our standard deviation is much bigger. It's 15. Okay, well, how many people scored within one standard deviation? So 55 and 85 is all within one standard deviation, 68%. That's a much bigger range of data, right? Than our five. Our 5 was much more surrounded around the mean. That means our data is much more reliable. So small standard deviation, large representative sample. Okay, statistically significant comes up a lot. It's a term that you have to know. So what this means is that if I'm reading research and it says these results are statistically significant, you should be like, ooh, that's an important word. Hold on. I know what that means. That means the odds that these results occurred by chance are less than 5%. Okay? So we're not saying for sure that our hypothesis is correct, but the odds that it happened for any other reason than the independent variable that we're looking at are less than 5%. So it's a really good chance that these results are due to our independent variable. We're not saying that it's for sure fact, right? Because we're always retesting in science. But we feel good about this. This is important. You should look at this data. It is significant. And if you put that in a numerical language, that would be over here on the right. So see that our p-value is 0.05. So if it's less than 0.05, that means it's statistically significant. So our takeaway, so measures of central tendency, it's all about finding that center. Where do most people lie? So mean, median, and mode. And when the data is really skewed, when Bill Gates walks in that coffee shop in Reading, Massachusetts, we don't want to use our mean. That will get skewed. We want to use median. That's much more, that will tell us a much more accurate picture of Reading, Massachusetts. The measures of variation, we are looking for how the data varies from that mean. So we want to look at standard deviation in that case. We want to see in our research studies, we want to see a big representative sample, but we want to see a small standard deviation. Another thing I could have added right there too is our 68, 95, 99 rule, right? A normal bell curve should be 68% within one standard deviation, 95% within 2 standard deviations, and 99.7 within 3 standard deviations. That's a good bell curve. And finally, statistically significant. I will happily go over this more in class. I know that term is a little bit confusing, but you should be familiar with it. And when you see that in research, you should say, okay, this is basically like saying we really like our hypothesis now, but they're never going to say, oh, we've proven our hypothesis, because scientists just don't say that. They just keep testing. All right, so I hope this was helpful, and I will see you in class for